So let's start off our discussion with life cycle cost analysis. And when we say life cycle cost analysis, a lot of times folks are asking, why are we talking about this, Tom? This is a cost estimating course. Why are we doing a life cycle? Well, the costs that you have to consider are entire life cycle costs. And you might be thinking, wait a minute, Tom, I'm just a guy in the shops. I'm just a person sitting over in ops engineering. I'm just a person sitting in the drafting shop. Why do I have to deal with the life cycle cost analysis? Well, the purpose of this lesson is to convince you, the bottom line here, I'll give you the whole thing right now. Everybody has an input into the life cycle cost analysis. And the idea is that when we make decisions in CE, when we make decisions for the Air Force with taxpayer dollars, we need to consider more than just the initial investment. We need to consider the entire costs across the life of those assets. And so we're going to take a look at that. The idea is, for example, this is an example, it's a real world example. We've got a construction project and they've installed some sort of footer for a column, okay? And then after the contractor did everything according to what they're supposed to do, rain comes in and undermines that footer. So you can kind of see the little gap down here where they undermine that. Now, you've got two options. First option is you can go out there and look around and say, okay, push the dirt back down and we'll call it good, okay? That might cost you a little bit of dollars, $250. It's just, I said, well, that's a big guess as far as what that would do. But it might cost you a little dollars, but in the end, there's going to be some settlement issues. That undermined foundation is going to sink, and we're going to have parts of the building that are going to pull away from the other parts of the building, are going to cause major cracking, maybe things are going to sag, maybe impact the mission of the facility, and you will end up with millions of dollars in damages. Or you could have the contractor come out and jack up the structure, pump in some structural grout. That might cost you, let's say, $25,000. All right, what's the right thing to do? And most of you are saying, well, obviously, the right thing to do is to build the building right up front, okay? That's the right thing to do. But the question is, why would you be pushed to do something different? And does the fact that, this is a little copyright acknowledgement, but does the fact that this thing turned out to be an IG investigation show you that there's people who are really indeed pushed to do the things that are not necessarily smart? And so the question is, how do I empower you? How do I empower you to show your supervisors and show the people who are pressuring you and show the people that this is the right way to do business? All right, so this whole analysis thing empowers you and enables you to do what you know is right in the first place. All right, so the mandate. I'm going to go through a number of policies and documents. I will tell you that I record this lesson a couple of times every so many years, and the reason is that AFIs change and the DODIs change. But I will tell you the language has not. They may change the shape and name, the language does not. Now, and I will tell you one of the main things that's going on right now, Air Force instructions and Air Force manuals are turning into Department of the Air Force instructions and Department of the Air Force manuals. Why? Because we have a Space Force now. And so as a result, you might see some of these things change their names in the future. I'm not re-recording the video because the language hasn't changed. The truth of the matter hasn't changed, okay? Executive Order 13327 states that we are going to make decisions based upon life cycle cost analyses. Then we have a DOD instruction that says that essentially you're going to be considering all of the reasonable alternatives when you're making decisions and investing taxpayer funds, and you're going to use the entire life cycle costs to do so. Sounds pretty high level and esoteric, doesn't it? But then we go into the Air Force policy document 3210 that states when we manage infrastructure installation and facility manners, we're going to minimize life cycle costs and risks the ownership, maximizing long-term benefits to mission. In other words, we're going to meet the mission at the cheapest cost, life cycle. So it gets down to Air Force Instruction 321023. How are we going to implement this? Well, when we're building facilities, we're going to use life cycle cost analysis to maximize our project and optimize our project costs. Now, this sounds a lot like what the engineering flight would have to do with major projects, right? So a lot of you folks, again, I'm telling you, the folks who are sitting in the ops shop, the folks who are sitting in the programming section and the ops engineering, you're probably thinking, yeah, that's when we do milk. No, it's not just when we do MilCon. 32.10.20. One of the fundamental paragraphs is base civil engineers must determine project solutions that meet the mission at the lowest life cycle cost. So it basically repeats that executive order. And then it repeats it over and over and over again on throughout the entire document. 32.1001. Now, why is this one important? This is the ops flight AFI. Okay, so it's not just the engineering flight and major projects that we're dealing with. We're dealing with all the work in the ops flight. The ops flight role is to focus cost-effective infrastructure management solutions across the entire life cycle of assets. So life cycle costs. So the important thing I'm trying to get across here is it's your job to consider life cycle costs in all decisions. Here's another scenario. You need to replace the sump pumps in our steam tunnels across the base. Now there's approximately, let's say, 150 sump pumps, okay? So here's a little picture of a steam tunnel, and there's a little sump pump that's pumping water right next to the pit. I'd love to see that. Yeah, that water's just short-circuiting right back in. But nonetheless, it's got a sump pump in there. You get a couple options. Standard off-the-shelf replacement pump, that's what they have in the pit. You're going to go in there and replace that. It's $950 each. However, you can get a high-efficiency, low-maintenance pump with longer life at $4,500 each. Okay, which do you do? And why? Okay, so you got to figure out, and most of you are probably already jumping right into, well, how long does it last? And what kind of low maintenance? How much is it going to reduce in my maintenance? And what kind of high efficiencies? How much energy are we going to save? So we're going to start thinking about that as far as quantifying that so we can do the life cycle analysis. And does it make a difference if it's 150 pumps or just the one pump you're replacing? Now you're starting to get into your shelf stock and what kind of training our people might need to have and all that other kind of stuff that goes along with it. So it's consideration for everything we do. So what is a life cycle cost? So we'll go into the Code of Federal Regulations and it defines it for us. It's the total cost of owning, operating, and maintaining a building over its useful life. So I've got this highlighted that we're dealing with not just the initial construction. The initial construction generally is about 10 to 20% of the total life cycle cost that you'll ever run into. The utilities, the repair, the operations far outweigh the initial construction of that facility. And so those things have a dramatic impact on the long-term decisions that you have to make as far as what kind of building systems you put in there. And I put this chart up especially to emphasize this is not about major projects. Most of the time when we talk about economic analysis, we're making the decision, do we build a new building, do we replace the building, or do we do nothing at all? Or repair the building or do nothing at all. And everybody thinks that that's the total beginning to end of life cycle cost analysis. That is so outside of the realm of what we can do for the taxpayers. I mean, that's a major big decision making. That's something we can hold up in front of Congress and it ends up in the news as far as whether we're investing in new facilities or repairing facilities. All right, so we can do that. But this kind of decision making far outweighs that. You can save much more money for the government by the day in, day out decisions that you make. Do we buy or lease a special purpose piece of equipment? When I was chief of ops, many times as chief of ops, I had folks on a regular basis came to me and said, hey, we need to rent this thing. And my answer was, well, why aren't we buying it? Are we using it that often? Tell me what you tell me what. And so I looked at the shops to feed me the information to make a life cycle cost decision. Or if they wanted to buy it, I said, well, wait a minute. Why are we buying this thing for once a year type of use? Why aren't we leasing it? So let's talk back and forth and figure out what's the right decisions. It's not that your decision's wrong. It's just make sure I understand what the right decision is. Do we maintain something or let it run to failure? Classic corrective maintenance versus preventative maintenance discussion. Do we replace or repair the shop piece of equipment? All right, so I've had folks come in to me and say, I've got something broke, we need to replace it. And my answer is, well, why aren't we fixing it? Well, the fix, won't last this long, but it's only going to, $150, and back and forth we talk about it. But I need the life cycle cost to be able to make those decisions. Do we install one system versus another system? All right, this is the classic ops engineering versus engineering flight decision. You make countless decisions day in, day out about what you're going to do about a requirement that is life cycle cost impacted. And replacing with what is already in there isn't necessarily the right decision. You need to think through that every single time. Do we do with low quality but inexpensive, or high quality but expensive? Decisions that you make all the time. Asphalt versus concrete. All kinds of decisions are made daily in every single facet of the CE organization. And you folks are feeding those decisions. You may not actually be the one making the decision. I understand that. But you should know what the decision makers want to know. Now, there are a number of different life cycle cost analyses out there, and we're going to talk about a number in this course. We're going to talk about the full and formal economic analysis. Absolutely. You're going to hear what full and formal economic analysis is all about, because it's a requirement that if you do certain projects, you have to do one of those full and formal economic analysis. Do I build a new building? Do I replace a build or repair a building? Do I lease a building? Do I do nothing at all? So those types of analysis we're going to talk about. Then we're going to talk about alternatives analysis, which is the day in, day out project level analysis that you need to do per the business rules in accordance with the comprehensive planning platform. So if you're in a programming shop, you know what I'm talking about as far as doing the CPP vector checks and things like that. Then we're going to talk a little bit about some systems that are available for you. So the building lifecycle cost analysis system for energy programs. And then there's a project savings wedge calculator worksheet that we'll look at to support those simplified analyses. Builder itself has work planning based on degradation curves and system costs. So part of the builder system is life cycle cost analysis. But I'm going to teach you how to do it so that you understand that all of our decisions and all of the things that you face, you need to know what is fed into those decisions. See, here's a great example. You've got two different alternatives. If you're working on a roof, you might have a built-up or a single-ply roof, and you might say, well, we'll go back in there with a single-ply roof. Why are you doing that? Why wouldn't you put a sloped roof in? Because the Air Force has been, by policy, been in favor of putting in sloped roofs over flat roofs for, well, let's see, since I was a lieutenant, at least 35 years. And so why wouldn't you do that? Well, you have to take a look at the life cycle costs. And the real question is, how do you compare these on the same basis? I mean, they're 15 versus 45 years. There's a lot more costs over here, but it's spread out over a longer time frame. How do we put these things on the same basis? How do we make decisions based upon that? And that's the challenge. That's what we're going to get into for the next dozen or so lessons. So the key things to take away from this: life cycle cost analysis is mandated. We've got to do it in all investments we make. No, I'm not just talking about the major investments in the engineering projects. I'm talking about all investments you make. If I'm the chief of ops, or if I'm the chief of ops engineering, and you come to me with here's what we need to do, I'm going to ask you about life cycle costs. Because all investments and all decisions we make have to be based upon the life cycle costs. We have various levels of cost analysis, but everybody's involved. You may not make the decisions, but you certainly feed those decisions. And we need a common frame of reference in order to consider all these costs, and we'll learn how to do that over the next lessons.